In the second question, you have to find tangent and normal. Okay. First, I tell you how to find equation of normal. Equation of normal is, sorry, first I tell you equation of tangent. Equation of tangent is what? The normal vector del f upon del x. Okay. X minus x0 del f upon del y minus y0 and del f upon del z minus z0 is equal to 0. So first of all, we have to find del f, del x, del y, right? Understood? Yes. And what is f? F is nothing but x square plus y square minus 4z. This is vector f. Sorry, function f. So del of x will be 2x. Del of y will be 2y. Del of z will be minus 4. So at point 2, minus 4, 5 is what? 4. Okay. And this is minus 8. And this is minus 4. Right? Put all these three values here in the formula. This is the standard formula for finding equation of tangent. So del f upon del x is 4. X minus x0 is, this is x0, this is y0, and this is z0. Understood? So x minus 2 minus 8, y minus minus plus 4 is equal to 0. Up to here you understood? You can go through once. Yes. Now simplify this. Understood? Yes. When you simplify this, you will get 8x, sorry, 4x minus 8, 8y minus 32, 4z plus 20. So 4x minus 32 plus 20 means minus 12 minus 20. Minus 20 mm, minus 40 minus 20 minus 20, take right side. Divide by 4 on both sides. You will get x minus 2y minus z is equal to 5. Right? This is your final answer. Right? You can check the answer. Understood? Whatever function is given, find its partial derivative with respect to x, with respect to y, with respect to z, and put all these value here at the given point. Understood? This is nothing but basically depend on the formula, right? So this is standard formula for equation of tangent. In the same question, equation of normal is also asked. Understood? So equation of normal will be, here multiply is there in tangent, and in normal it is divided. So equation of normal is nothing but x minus x naught divided by del f upon del x. Understood? But here write equal to y minus y del f upon del y. Z minus z naught del f upon del z. Okay. So x naught is 2 and del f by del x is 4. y naught is minus 4, so it's become plus, and this is minus 8. Z minus 5 is equal to minus 4. Understood? Yes. So x minus 2, you can divide by 4 on all sides. When you divide, you will get 1 minus 2 minus 1. So x minus 2, right? Uh, this is minus y plus minus 2 upon 2 minus 4 upon 2, 5 minus z. This is equation of normal. Understood? Yes. So it's very simple. I think you understood. Okay, can we move? Now see question number 3. See question number 3. T denote unit tangent to the curve. So first of all, we have to find unit tangent, right? And we have to prove that capital T with respect to capital T upon small t is 0. So first write what are given. X is equal to 2t, y is equal to 3t plus 4, z is equal to 3t. What you have to prove? dt upon d small t is 0. And what is capital T? Right here also. T is unit tangent curve. Okay. Okay. So first of all, we will find position vector. Always remember, whenever in the question it is not given, always remember position vector is always RT. Okay. Yes. Now substitute the value of x, y, and z here. This is nothing but a position vector. Okay. X is 2t. Understood? Now we will find velocity vector. What is velocity vector? You know, position vector with respect to t, right? So when you differentiate with respect to t, you will get 2i, 3j plus 3k, right? Yes. This is what velocity. Velocity means what? The rate of change with respect to time, right? Right. The rate of change of position vector with respect to time is velocity, right? And how to find speed? Speed is nothing but modulus of velocity, right? Root 22. But in the question, t is unit vector. Unit vector is what? The vector upon its modulus. So vector is upon root 22. Up to here you understood? But you have to prove what? dt upon t, right? So when you differentiate this t with respect to small t, you can see this is a constant vector. Why constant? Because there is no small t, right? So when you differentiate with respect to t, you will get 0, 0, 0 means 0, right? Yes, it means the unit vector will not change with respect to time. dt upon d small t is 0 means t is not changing with respect to time because unit vector is independent of small t. Understood? You can go through once so that you can understand. Uh, Only one new thing is there. Start from here, position vector. Okay. Position vector is what? Let's suppose a point. X-axis, y-axis. Let's suppose a point is there. Okay. X, Y, Z. So you don't know, you don't know the actual distance of, you don't know actual position vector. That's why you have to consider and it starts from here. Okay. Go through once this. Understood? Whenever you see RT, RT is what? Position vector. Okay. So always find velocity. Velocity is what? The rate of change of R with respect to t. Right? This is velocity. And what is speed? The modulus of velocity. Okay. And what is acceleration? The rate of change of velocity with respect to time. Okay. It means R second derivation of R. Right? So acceleration is what? Either you can write v dash t, derivation of v, or double derivation of RT. So this three-step process solves almost every basic velocity acceleration problem in vector calculus. Understood? Yes. So this is position vector. Position vector means what? Displacement type vector. So when you differentiate a displacement with respect to time, you will get velocity. Speed is nothing but a modulus of velocity. Acceleration is nothing but derivation of velocity with respect to time. Okay. Our second derivation of velocity. Understood? Second derivation of position vector. Now see question number 4. It's basically depend on formula. You have to determine the velocity, speed and excellence. Oh, this is very simple question. Position vector is given. cos t plus sin t I. Sin t minus cos t j. You have to find what? Velocity, speed, and acceleration. Can you find this? What is velocity? dr by dt, right? Yes. So cos t is what? Minus sin t. Sin t is what? Cos t. I. Sin t का cos t. Cos minus minus plus j. This is velocity. Velocity vector. Don't say only velocity. Say velocity vector. Because t is not given, right? T is not given. So velocity vector, this is velocity vector. So write in Vt in terms of t, right? Okay. What will be the speed? The modulus of velocity vector, right? Yes. Minus sin t. Square of each component and take root. Open the bracket. A square b square minus 2ab. Sin square theta plus cos square theta is 1. So 1, 1, 1. How many ones are there? 3. So his speed is root 3. Okay. Now find acceleration. Acceleration is the rate of change of velocity with respect to time. Again, you have to differentiate this, right? So sin t is what? Minus cos t minus sin t minus sin t. And there is no t component, it is 0. So acceleration will move in only two directions, in x-axis and y-axis. Okay, this is acceleration vector. Understood? That was very simple question. See, question number 5. A particle moves with constant speed, right? Constant speed so that acceleration is perpendicular to velocity. Oh, it's very easy, no issue. Constant speed means what? Speed is any constant, and this is c. Okay. If the speed of a particle is constant, so that the acceleration is perpendicular to velocity, right? Okay. First, you see what are given. Speed is constant. And what is speed? Modulus V, right? And constant C is given, right? From here you got one thing. What? Vector modulus of vector V is C. Understood? Okay. What do you have to prove? This is very important. Acceleration and velocity vector must be equal to 0. Okay. You know two vectors, if dot product of two vector is 0, then this is perpendicular. And which two vectors are perpendicular? Acceleration vector and velocity vector, right? Yes. Understood? Yes. Now see, it is given. Now, when you do square on both sides, right? And you know modulus v square is nothing dot product of same vectors, right? You know the dot product of same vector is nothing but modulus of square. Understood? Okay. Now differentiate with respect to t on both sides. You can notice one thing. This is a constant and derivation of constant is 0. Understood? And use here chain rule, product rule. You know, product rule is what? When you do derivation, you know u v dash plus v u dash, isn't? Similarly, consider u and v here. So you will get dv by dt, v by dv by dt. Understood? Both are same thing, right? Na? Both are same thing. A plus, let's suppose this is A and this is A. A plus A is 2 times of A, right? Okay. And you know what is acceleration? D by dt. So you can write 2v dot A is equal to 0. Understood? Indirectly, you can write velocity and dot product of velocity and acceleration is 0. If the dot product of two vector is 0, then definitely you can say vector velocity is perpendicular to acceleration, right? Since two vectors dot product is 0. If the dot product of two vector is 0, definitely they are perpendicular to each other. And what are the vectors? Velocity vector and acceleration vector. And this you have to prove. I think you have understood, right? Yes. When speed is constant, acceleration cannot increase or decrease the speed. It only change the direction of motion. Okay. So this is question number 5. You can go through once. Then I will tell you next question. Today I will finish vector differentiation. From tomorrow we will discuss vector integration. In vector integration, 2 class is enough. Okay. Just go through once. Always here write dot product. Now question number 6. Yesterday we have done. Question number 7. Yes, done. 8 done. 9 done. 10 done. Yeah. No. 10 not done. Okay. 10, 11 not done. And rest all done. So all the questions which contains scalar function, vector function, divergence, curl have been covered. Okay. So from tomorrow or in next class, we will cover integration part. Integration parts come from question number 18. Okay. Now I tell you question number 10 and 11. Read the question number 10. You have to find directional derivative. Yesterday I tell how to find directional derivative. Vector phi is what? At 1, 2, 3. Right? Now the problem is what is the vector u? So it is given purposefully so that you become confused. Here vector u is nothing but this 3, 4, and 5. Okay. Now you can find, right? Grade phi. Grade phi is what? 2x, 2, 4, 4xi, 2ij, and 2zk. Right? At 1, 2, 3, grade phi. So 1 is 4. Okay. So directional derivative of phi along vector u is 3i 4j 5k upon modulus of vector u. Right, this is your answer. Understood? It's very easy, no issue. Now see question number 11. First part is easy. Second part is also easy, but question is new. So I will tell you this also. And C part also new part. So F is given 2 minus 1, 1 in the direction of 3, 1 minus 1. Okay. So first of all, we will find grade F. Grade F, can I write directly? minus 2z. Understood? Okay. And what is vector u? Vector u is 3, 1, minus 1, minus 2, minus 1, 1. Why I am doing minus? Because read the question. In question, from this toward this direction, right? So from this point to this point. So vector will be minus. Understood? 1, 3. Okay. So question A is very easy. Directional derivative. Dot product with I plus 2j is 0 p. Minus 1, minus 1. This is minus 2. So minus 2 plus 8, 6 by 3. 2 is the answer. Here 2 root 11 is there, but 2 is the answer. Okay. Yes. So whenever you are asked to find maximum directional derivative is maximum. Okay. So for a maximum directional derivative, this is the formula. Maximum directional derivative will be, so whatever you have, grade f, take its modulus. Modulus means it will be the maximum value. Okay, but here is the in which direction? Okay. So for maximum, it is, this is C part actually. Minus 2 square, 24, 2 root 6. Okay. This is maximum value. This is formula for maximum find. Whenever you are asked to find maximum directional derivative. For a maximum directional derivative, take the absolute value of this. Absolute value means take the modulus. And whenever you are asked to find maximum in which direction, the directional derivative is maximum. So I am doing B part. So in which direction? This is the actual answer. Okay. Grade f is the correct answer. What is grade f? 2i 4j minus 2k. For finding in the direction. Understood? Yes. Okay. So all the scalar function, sorry, vector differentiation had done. Now from question number 19, 19 to 40 are related to vector integration. Okay. Okay. One more question left behind. Question number 18. See, a function is given, constant function is given, okay, and you have to prove that phi it is a vector perpendicular to this, okay. This is a surface. So first of all, find the surface. How will you find the surface? Take RT. Phi RT is equal to C. And differentiate this with respect to T. Okay. You know RT is a tangent vector. Okay. Now when you open the bracket, you will get use chain rule. Del phi dot dr by dt. And derivation of constant is 0. Okay. Okay. Since this is theoretical question, dr by dt is a tangent vector. And you can see their dot product is 0. So grade phi is perpendicular to surface. Surface means tangent vector. Understood? Yes. I am taking a quick revision of whatever I have told you. See, what is grade phi? Grade phi is, see, there is no dot or cross product in grade phi. Phi, here phi is scalar. Understood? What is divergence phi? Don't say only divergence phi. Divergence of vector phi. And this is with dot product. Phi is a vector. What is curl phi? Cross product of phi. Okay. And when divergence is 0, very good. Right. Remember in this way, divergence means dot product, curl means cross product. And whenever dot or cross comes, it means both must be vector. If divergence is 0, this is solenoid. If curl vector is 0, 0 vector, this is irrotational. Okay. Yes. Why you are using grade phi? For making it in vector. Understood? Yes. And what is scalar potential? Scalar potential is nothing but potential function. Finding a scalar value from the given vector. Okay. Using this formula. Understood? And what is equation of tangent? Del phi by del x, x minus x0. Del phi by del y minus y0. Hmm. And what is equation of normal? I'm writing here. X minus x0 upon del f upon del x. Understood? At the given point. I think these are one more thing, directional derivative. Directional derivative of phi along vector u is grad phi dot unit vector. Understood? So these are all about vector differentiation. In next class, we will start vector integration. In vector integration,